Welcome to the Modern Wellness Podcast. I'm your host, Dr. Mary Pardee. This podcast, along with my private practice in LA and my newsletter, all are aimed to providing you evidence-based information around preventative medicine, longevity, and health in general. Join me in dispelling health myths as well as cutting through the noise that is social media. I hope that whether you want to optimize your performance or just in general get healthier, the Modern Wellness Podcast will help you do that. Today, I was joined by Dr. Kevin Folta, who's the professor in Horticultural Sciences at the University of Florida. His research examines how specific light wavelengths control plant processes and how various genes influence fruit, crop flowering, fruit flavor, and aroma. He has been recognized with numerous awards in research and science communication. His main passions are public engagement in science and helping his wife, daughter, and son farm fruit, vegetables, chickens, turkeys, and pigs near Archer, Florida. You can find them all selling at the farmer's market every Saturday. He has his PhD in molecular biology. So you have a little bit of background. I was just talking to a friend about GMOs, and I was like, I should do a podcast on this because I feel like it's a really misunderstood topic. And I was just going to do a quick Instagram reel, and I was like, wow, I'm unequipped to answer, to do this on my own. And I was like, I need to find an expert. And that's where you come in. And this is me scratching the surface. And I want to keep kind of diving into this topic because I don't know anything about it. So as a listener, you guys are on this journey with me. We're learning here together today, and I'm really grateful to have you.
Well, thank you for having me aboard. I really appreciate the opportunity.
Awesome. So let's just start with the topic of what is a GMO?
Yeah, so this is something that is horribly misunderstood because the word GMO, or the term GMO, is so horribly imprecise scientifically. And when we're referring to that, we're referring to a technology of plant genetic improvement. And why do we need to make things improved? Why aren't they fine the way they are? We've been doing it for a long time. We have been improving plants in a very, I would say sloppy, but more of an educated guess way by combining two different plants that might have good traits together. Maybe one that has good resistance to disease and one that has good flavored fruits or vegetable. And we can combine those two together and hope that the next generation gives us something where those two traits are combined in one. Using genetic engineering, which is really the way I like to frame this, is where we're able to precisely take the gene that causes a trait and install that into a different background. So it's just much more faster and much more precise. And we're not bounded by sexually compatible plants, meaning we don't have to strictly have things that we can cross. We can bring even cross species or even kingdoms, and we can bring a gene from bacteria into plants that might allow it to be resistant to disease. So in general terms, the term GMO, and that's the last time I really want to use it today, means a plant that has been genetically improved through precise integration of changes in genes through the laboratory.
Okay. And why is that the last time you want to use that term? What are you going to use instead so I know?
Yeah, so I'll be a little more precise. I'll talk
Yeah.
about genetic engineering, and that goes back to my graduate student who years ago said, the term modified doesn't work. Would you rather cross a engineered bridge or a modified bridge? It kind of is implicit with it being a sloppy process, and really what this is precision. This is as good as it gets in terms of scientific precision.
Absolutely. And so people know when we're talking about this, what are examples of everyday crops that are probably included in this topic?
Yeah, that's really a surprise for most people because if I even ask a very astute class of university students, they'll say tomatoes and wheat and go down the
Corn.
list. And very well, corn is, yeah. So there's very few things that are though. Tomatoes and wheat are
Mm.
not. The only things that are, there's four things that are commonly contributing to the diet in the United States, and that's corn, soy, sugar beets, and canola.
Okay.
Those four things. And those make the starches, the oils, the sugars that are the ingredients that go into processed foods. There are the other things that are as whole produce are Hawaiian papayas, so very few papayas in the mainland, and one apple, called the Arctic apple, which is mostly used in processing, the pink pineapple, which is now starting to be available, but that's pretty rare, and one more thing too. There's some acreage of squash, but it's in zucchinis, but even that's kind of waning. So it's really just those first four things: corn, soy, sugar beets, and canola.
Okay, so you're telling me like strawberries, most of them are not genetically modified, or other
None of them.
vegetables, or this is this
Nope,
is this is
nothing.
complete news to me.
Yeah, so yeah, this is and this is the big surprise, right? And for me it's kind of sad because we have a technology that can do some really good things that has not been employed across broader species. And strawberries, gosh, I work with strawberry growers here in the States, and they would in the state of Florida, they would love to have some way to never have to spray a fungicide again.
Hmm.
But when we genetically engineered the strawberry to do that, they weren't terribly interested because they were concerned about consumer backlash. So it's an issue where we could do some beautiful good things with technology, but we are not doing the most we can. So many great solutions that are just on the shelf.
Because the people, or I guess it would be farmers, producers, think that people are not going to buy this because of the misunderstandings that are here.
I think that growers organizations mostly fear that consumer
Hmm.
backlash, whereas the big commodity crops where you can make where it really does change the dynamic for the farmer, where farmers can make great profits because of the technology. There it makes some sense. But when your industry is only a $300 million industry in the state, and it's going to cost $130 million to deregulate the product, it's just not worth it. And my state, we're in Florida, and we're going through a citrus crisis. We're down 90% in our production because of a disease. And in 2005, the big producers, or the big users, the Cokes and Pepsis who make Tropicana and Minute Maid, they said no genetic engineering. And now we're down 90%, and they're saying, hey, you guys got that genetic engineering thing going on?
Hmm.
And and now it looks like a great idea, right?
Hmm.
So we can learn from its implementation. In cases where we didn't, it's a great idea that we don't always use.
Okay. Okay. And we're going to dive into what you brought up in terms of fungicides in a little bit. But first, I want to talk about the safety testing that exists currently for new genetically modified kind of crops before they reach the market, what that looks like.
Yeah, it's pretty awful in terms of the amount of hoops you need to jump through in order to have something tested. It testing happens at multiple levels, and it is a joint effort between the funding, not between the funding, between the testing organizations, the regulatory organizations, and the company that has made the product. So if you are the company that makes the Arctic apple, want to bring that to market, you have to go first through the FDA to show that it's safe to eat. You then have to go through the EPA to show that it's safe for the environment. And then you have to go through USDA APHIS, which asks if it's going to be possible to cross-pollinate with other things in the area, or if it's safe to grow. And it doesn't go through all those at the same time. It goes through one and the next and the next. And it's a very expensive and time-consuming process that one estimate was $130 million and 13 years of test results that have to be shown in order for something to get to market. So it is really arduous.
And I'm sure, like any industry, some of it feels like too much. But as a consumer, too, we want those safety things there, right? Like we want some level of ensuring that it's safe for us, for the environment, for the other species. Is that what you feel?
Oh yeah, yeah, and everybody's on the same page there. The consumer demands it, and they
Yeah.
should. But the companies also need to have it because you have one unsafe tummy ache from a product you produce, and you're going out of
Hmm.
business. So it's a this is a an orchestration between multiple organizations and at the federal levels that are ensuring that these things are safe. And in the 30 years that these have been going in the field now, there has not been one single health event associated with products from genetically engineered crops. So very good safety record.
Great. Um, Main reasons that people develop GMO crops? Is it more about yield, nutrition, environmental impact, combination?
It's a combination of things, but at the end of the day, it's about sustainability. Sustainability has three legs on the stool. It's economic sustainability, and it's environmental sustainability, and social sustainability. The economic sustainability is a huge part of it. How do the 1.5% of farmers in our well 1.5% of our population is a farmer, and how does this very small portion of the population stay in
Mhm.
business and be productive? And that means requiring technologies that can help them do more with less. How do you get farmers to be able to farm with fewer pesticides? How do they, which are super expensive, how do they maximize fertilizer, diesel, yield, or I'm sorry, labor, all those things in order to be able to continue to farm profitably? So the major traits have been on those areas.
And I just want to
How
add
do you, how
something
do you,
too, because it's not
yeah.
just keeping farmers in business, it sounds like, but keeping prices at a reasonable place where farmers can still be in business, but the consumer can also still afford fruits and vegetables.
That's a huge part of it is access. And the problem that most of the genetically engineered corn, for instance, most of that's going to animal feed,
Mm.
and a lot of it to ethanol. And so it's keeping the cost of gasoline and keeping the cost of meat exceptionally low, maybe artificially low, some would argue. Very little of that is ending up in the human diet directly, other than those products I mentioned earlier, like oil, starches, and sugars.
Hmm. Hmm. And let's talk about some of the nutritional kind of things there. Have there been GMOs that have been developed for nutritional reasons specifically?
There have been, but they've never been
Mm.
deployed, and it's such a heartbreak. 30 years ago now, almost, they came up with golden rice, which was rice that had a higher level of beta carotene. That's the orange stuff in carrots. And this was designed for the developing world where vitamin A deficiency leads to blindness and immune breakdown and eventual death in something like 1 million children a year.
Wow.
And it's just that one vitamin they're missing is vitamin A, which comes from consumption of beta carotene. And it was opposed by organizations like Greenpeace. It was fought tooth and nail, still is. And it was approved in the Philippines in 2021. We were very excited to see it first get rolled out, and then it was pulled back in 2023
And
or
why was it
2024.
pulled back?
Because organizations still have a great deal of fear about the use of genetic engineering, and it's just as safe as a carrot. I mean, there's nothing wrong with it, and so now it's still in limbo. But since 30 years ago, scientists have put this into the bananas that a large part of the population uses in sub-Saharan Africa, the matoke
Mhm.
banana, starch banana. It's been put into soybeans, it's been put in the potatoes, it's been put into so many different crops that people use as world food staples, which typically are rather vitamin deficient. And none of these have been able to reach the people they were meant to serve. And that's a heartbreak.
It's fascinating to me. So, the one that you were talking about in terms of the golden rice, there was no negative outcomes to it. It was just a reversal of the decision that was made due to fear of what potentially could happen.
It was all by fear and disinformation, the internet being a wonderful conduit to levy bad information that people, it's very easy to scare people about food. It's so important to us socially and in our families. We gather around the table and to introduce the idea that this might be, 1% chance this could be a problem. That's enough to stop people from using a food technology. But I'm on the side of the folks in the developing world. How do we feed more
Hmm.
people with and this would have been a great strategy.
And how do you think this differs from the fortification of food? Because we fortify different foods here in the US in terms of, I believe, like
Sure.
folate, right? We put in a lot of things. We put different minerals in different foods. Iodized salt is something that we do to prevent iodine
Sure.
deficiency. Why does this seem so different?
Yeah, it seems so different because the plant is making it itself, which is great, right? You don't have to add it. You don't have to spend the money on beta carotene supplement to put it in. The plant makes it itself. And this is a really strong part of it. It feels different because we're adding the gene that controls the production of this stuff, which naturally occurs in leafy green vegetables and carrots, as I mentioned before. So we're just taking that pathway from one fruit or vegetable and moving it into another. And it produces this compound, which would be such a benefit to world health if we could actually use it.
Yeah. Yeah, it seems like a no-brainer to me, but I want to get to one of the things that I do have a question about where I would have like a little bit of gun shyness, I would say. And that's this idea that if I think people believe that the main thing that we're using GMOs for is to increase, or how should I say this, to make plants resistant to pesticides and herbicides. And the fear of that we're using much more of those chemicals that will then get passed on to humans when we consume them. Can we talk about that? I know it's a big topic.
Yeah, so no, but it's a good one. So let's break down what pesticides are. Pesticides is a big umbrella term that means herbicides, insecticides, fungicides, antimicrobials, right? So you're targeting pests, whether they're weeds, insects, fungi, or bacteria. So that's the big term of pesticides. So if you look at genetically engineered crops and say, did they increase pesticide use? The answer is absolutely they did, because we use a lot more herbicide than we did before. But let's look at this more carefully. If we say, did we increase the use of insecticide? You see that we radically decreased the use of insecticide massively by using a genetically engineered crop that makes its own protection against insects. So the crop itself makes a protein that is lethal only to specific insects. Very, very, very narrow range. And I'm glad to talk about that. We call this BT technology. That is, targets specific insects that feed on that crop. And so you don't need to bring the spray plane with insecticide over and kill every insect in the field. Only the ones that bite the crop get sick from the crop and die from it. So insecticide levels, way down. Fungicide levels, we don't really have genetically engineered crops that have been approved with fungicide resistance. And that's okay in a way because the fungicides we have are becoming increasingly more selective and very low amounts that are being used over an entire field. The one that people get concerned about is weed control. And here is where we have herbicides where use has gone up, way up, because the amount of acres of herbicide tolerant crops has gone way up. It's a really good technology that works fantastic. And the way it works is, and this is the compound glyphosate, which is the ingredient in Roundup, as one of the many brands of herbicides, many formulations. And this is the one that's gotten a lot of negative press. The farmer plants the crop, and as the weeds start to grow and the crop starts to grow, the farmer can then apply the glyphosate over the top, kill the weeds, leave the crop. So there's very little of the herbicide around once the product, the soybeans or the corn, form on that crop. And that is a really good technology that has worked well, has some limitations, of course, but in general has been really great. And it's been so good that the number of acres that farmers plant goes up. And that's why the amount that's been used has gone up. Same amount per acre, a lot more acres.
So it's not
And
that
so that's why,
individual plants
yeah,
are getting sprayed with higher doses of these herbicides. It's that there's more plants to spray. So, of course, we're going to be using more of the herbicide.
exactly. The amount that's sprayed is ridiculously low. It's about 2 soda cans per acre of the active ingredient. It's extremely potent against plants, not that potent against anything else, which is makes it a unique chemistry.
Okay, so again, I'm learning here, so I want to make sure I get this correct. Would you say then that the use of GMOs is not increasing the amount that a single plant is sprayed?
That's right.
That's
Yeah, it's in some cases maybe yes, but in general, but a little bit. In general, it has not increased the use of herbicides on a per acre basis.
Okay. And the little bit is, what's that about? Because I know people will ask.
Sure. So in some cases, and this is one of the major drawbacks of the technology, is that you see resistance of weeds to the herbicide. And so we have to spray them with a little bit more in order to knock them back. And that only works on some disease, on some weeds. So just as a quick downside of this technology, it's not all perfect at all, is that whenever you have like how we had antibiotic resistance in humans who misuse antibiotics, when farmers are only using that one strategy year after year, you start to see weeds evolve resistance. It's biology. And right now, in some places, there's so many weeds that are resistant that farmers, I don't even want to use this technology anymore. So then seed companies have to go back and use multiple herbicides, multiple strategies, and that's going the wrong direction, right? We want to use less. And so that's really where we are in the state of this right now, is that as the use of this breaks down and as farmers have to add multiple herbicides and increase the amount of use, that's not the direction where we really want to go.
But do you feel like there is a way to keep the system working in terms of having plants that are resistant to insects on their own so they can grow well but not lead to this resistance?
Yeah, there are ways to do it, and the insect issue is there is resistance to the internal protein. Okay, we know that already. There are strategies to mitigate that and slow it down, and sometimes it involves going back to old school pesticide control, insecticide controls. But the main thing with all of these strategies is to approve multiple mechanisms. So, in other words, don't rely on one herbicide, have one in year one, a different mechanism in year two, maybe a third one in year three. Use something different every year so that you never have evolution working around your strategy. The problem is that each one of those costs money to produce. And each one has to go through a separate regulatory channel. And back in the 1990s, when this was happening, folks like me said, you better have multiple ways to combat this. And the company said, no, this will never have resistance. Well, sure enough, I was right. You need to have multiple mechanisms.
Absolutely. And this is no different than antibiotics, what you're saying, in terms of if we know that somebody comes from a region that has a high resistance to a certain antibiotic, you don't use it in that person to make sure that you're not perpetuating that resistance. So hopefully we will learn at some point and figure out a better solution. All right.
Yeah, we're getting better.
Okay.
We're getting better, but I think it's a long way to
Yeah.
go.
What do large scale reviews and meta analysis tell us about the health effects of eating foods that have been genetically modified?
Well, this is an interesting question because foods generally are not genetically modified, and people are surprised by this. Everybody thinks, oh, I'm eating bioengineered food. The food you're eating is the ingredient that comes from a genetically engineered crop. So if I gave you sugar from non-genetically engineered sugarcane, I gave you a sugar beet that was grown organically, or sugar from genetically engineered sugar beet, you wouldn't be able to tell the difference. They're all sugar. The oils are just oil, and it doesn't matter where they come from. So there's no reason that we would anticipate a health effect, and we've never seen it. And when you look back at all of the different studies that have been done and all of the different places that they've looked, you never find any real reproducible effect of products that come from genetic engineering. I mean, they're just not there. The only time you see the nuts and bolts of the genetic engineering come along are maybe in starches, where you can still detect the DNA and maybe a little bit of the proteins. But in general, these are just innocuous proteins that are found in nature. The ones that are used to that we are adding to the corn or the soybeans, they're the same proteins that are in our environment. We're swallowing with every swallow of food because they're ubiquitous bacteria that produce the same proteins.
Yeah, and I feel like this has got to be a really hard field to actually study well, because if you're looking at people who are, let's say, eating sugar and corn that are derived from genetically modified plants, it's virtually impossible to look at a cohort that's eating sugar and corn that's not derived from genetically modified plants, right? In terms of comparing if they have higher rates of X, Y, and Z.
Yeah, that's true. I mean, but it's one of these things where we don't even have to go to cohorts to think about it. I think if we're comparing soybean oil and soybean oil, it's the same thing. And while, we can always think of ways that there are some unintended effect or something that we would see, I think that you would see that reflected in population-based studies or epidemiological studies of, in one way or the other. But I don't think that we've ever seen it.
So I polled my Instagram audience about if you avoid GMOs or if you think that they're bad for you, why do you do this? And I got a few responses, and by far the most common response that I got is that they're sprayed with more pesticides, and the pesticides are bad for my health, and they're going to end up in the food, and then it's going to increase the rate of cancer, blah, 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 blah. What do you say to that?
Yeah, so let's go back to breaking it down by the type of pesticide. The insecticides, it cuts broad spectrum insecticide. There's no question on that. It cuts that massively. In terms of herbicides, it does have herbicides, but they're sprayed early in development when the crop is just a few weeks after you plant it, and not sprayed again. You never spray this on the corn. You never spray it on the soybeans or the sugar beet itself. Well, on the sugar beet root, you would get some residual, but it's not taken up by the roots, taken up by leaves. The bottom line is that when they test for this stuff, and they do, I mean, this is a big thing for people these days to look for residual glyphosate, and you can find it. People are really good at it. You can find it at levels in parts per billion, and a part per billion is a second in 31.7 years. So very, very little residue there.
One
The
sec,
problem
one
is that
second in 31 billion years.
point 31.7 years.
30. Okay. Say that
1.7
one more
years.
time, just so.
All right. So a part per billion is 1 second in 31.7 years.
Got it.
And so that means that if you're looking at, 50 parts per billion, you're looking at under a minute in 31.7 years. And so very, very, very low amounts of this stuff that are present. The problem is that we're too good at measuring things that are almost not there. And somebody says, well, that number isn't zero, so I'm concerned. And I understand that. I got 2 kids. I worry about everything they eat. And I think but that's how people think about it. Unfortunately, that's a level that's so low that it's physiologically irrelevant. It can't do anything to you. You couldn't take drugs at 50 parts per billion and have and realize a therapeutic effect. You can't have exposure to residues at this level and have an adverse event. It just isn't even feasible from a pharmacological standpoint.
Yeah, the dose makes the poison, and we've talked about that many, many times on this podcast, where if we are going to say that everything that has a carcinogenic effect at a certain level should not be consumed, then we should never be in the sun, right? There's so many things where you'd be like, oh, but the sun's okay at low levels, just not if you get burned. Exactly. Like that's the point that is being made is that the dose is so important. Similarly, I have patients that want to taper slowly off of medications and they end up on like 1 milligram of Zoloft. And I'm like, it's not doing anything at this point. Like,
Ain't gonna do it. Well, that's a funny one. A funny one that you'll appreciate is that they have non-GMO vodka. So here you're taking something where there are trace amounts of something that is a highly disputed carcinogen, and yet you have at maybe 50 parts per billion, and here you have 130 million parts per billion of a known carcinogen of ethanol. And people, but they will have non-GMO vodka.
That's such a great example. And I love going back to alcohol because societally it is so accepted as a norm. And at no dose is it beneficial for your health. And at virtually every dose, besides like a dropper full, right? But like even one drink a day, we
Yeah.
see deleterious health effects from it. And yet, majority of the population still consumes it, and here we are talking about something that, and I'm still learning, so I'm not like putting my stamp on like all of the,
Yeah.
doesn't matter. I think it's a really interesting topic, and I think that it's so important that we start to question our own biases in this as to, are we just going along with this narrative that has been perpetuated year after year after year, Or are we coming at this from an actual evidence-based perspective of like, oh, we actually don't think that this is good for our health? And I think that's where we just have to be so much more of a scientist in this versus somebody that's just emotionally attached to something because they heard it and then the what if, like you said.
Yeah, you're exactly right. I think if we look at our priorities, it's really skewed, and that's because humans are bad at perception of risk. What is the most dangerous thing you'll do today is get in a car, and the residues in a bowl of cereal where you would have to consume 3,000 bowls a day to reach any kind of demonstrated adverse limit. People are afraid of that. So you're right on.
Yeah. Okay, so what do we say about the biodiversity in terms of like soil health? Anything that we should be thinking about there if we're using genetically modified crops, which then in turn increase, it sounds like herbicides that are there. Is that going to affect the health of the soil long term?
Well, let's talk about you mentioned biodiversity first, and that's a place where you do see some impact of the glyphosate tolerant crops. The worst thing for biodiversity is to put in a farm. You're taking a field that was there, plains or whatever, prairies, and you're changing it into a small number of crops that don't belong there. Okay, that were brought in from somewhere else. I mean, corn comes from Mexico, soybeans from Asia. There's nothing that's native in U.S. soils with very few crops that actually are here in a wild species. So we do affect the diversity of that field. And then when you look at things like glyphosate tolerance, it's so convenient for farmers that they grow more acres. So they plow under more of the diversity that's there. It's a victim of its own success. And farmers will use things like glyphosate on fence lines because it controls weeds very well. I know we do on our farm. That a lot of the native crops that are there, that are a lot of not crops, native weeds that are there that pollinators enjoy will grow on fence lines, and those get managed. So there is an effect on diversity. Soil diversity is an important topic that, again, I can't blame genetically engineered crops for as much as farming in general. That farming, we are growing crops, unless you're rotating your crops, even when you are, we're having an effect on soil. We replace that with fertilizer. In Florida, we're growing crops in sand. So essentially, we're using hydroponics, right? We're growing crops in sand and applying water and fertilizer to help them grow. But the bottom line is we need to feed people and we need to keep food prices accessible. And so we have to decide how much land do we really want to dedicate to that venture, which is super critical. We have to keep people fed and have to keep their access good. And in order to do that, we have to have some sacrifice. The trick now is, how do we incorporate techniques to allow us to not have to expand it and do the most on the space we have and intensify by having better genetics and better techniques to manage those crops? And that's the way we're going to solve problems going forward.
I'm so glad that you brought up this idea about the impact of farming on biodiversity, something that I'm was unaware of, but makes total sense, right? Anytime you're going to plant a single crop or even a few crops, but in an area that they weren't before, you are effectively reducing and changing the diversity of that area.
Mhm.
What about with pollinators? So this idea, I looked up like what are the biggest things that people, dislike about GMOs, and this idea that it's contributing to pollinator decline was one of those.
Yeah, I'm not seeing a lot of evidence for that specifically. I think we see when we convert farmland from a prairie to a farm, you see a change in how pollinators are displaced from that space. But our main pollinators, our main honeybees, are invasives. They brought from Europe. They're highly managed in hives for most farms. So almonds and other fruit and vegetables, nuts, are pollinated through managed hives. Small farms like mine, we grow we keep a lot of native stuff growing year round. We have a lot of weeds that we let grow, so there is a natural forage because they help us. We don't bring in hives. But pollinator health in general is more affected by sprays of insecticides. So things like, spraying general insecticides, even organic insecticides, can affect pollinators, the ones used on organic produce. So the best thing you can have is the genetically engineered insecticides or insect controls, where the plant itself is making the control. And they can control the beetles and the moth larvae that feed on them. Then that way we cut the use of the other sprays. So this is a real step forward in sustainability. I think would be much wider applicable across more crops if people had a positive view of the technology.
Yeah, great point. And I've heard people in the past say, this is somewhat unrelated, but they've said that, okay, if you have something in a plant that makes it resistant to certain insects, then if you consume that plant, it's literally, I've heard somebody say, it's going to poke holes in your intestines. Have you heard that one?
Yeah, I hear it all the time. And let me ask you a question. Do you like
I
chocolate?
love chocolate.
Would you feed it to your dog?
Absolutely not.
Yeah, so there are chemicals out there or compounds out there that are highly toxic to some organisms and not to
Hmm.
others. And so this is one such case. These proteins are amazing. They're called BT proteins, or they call them delta endotoxin is their formal term. But there are ones that are specifically toxic to beetle larvae. There are ones that are specifically toxic to moth larvae. And and the moth ones don't affect bees. They don't affect praying mantises. They don't affect lady beetles. They affect moths, the ones that feed on corn. So this is why they're so cool, is that they're so specific. And so these are eaten by humans. They're digested like proteins. They turn into nutrition and amino acids like any other protein. They don't poke holes in you.
I love that analogy. What is the biggest myth out there about GMOs that you wish would disappear? Like the one that you're like, oh, if I could just get rid of this one, I think it would be a better place.
Yeah, that they cause
Yeah.
cancer. I think that, we're living longer, and as we live longer, we start to see the onset of more long-term diseases and things like cancers, neurological decline. And I think that that is front and center in everyone's mind as something that could go wrong, especially because we see the earlier incidence of colorectal cancers among younger people. These are things that are in people's mind. They're in the media. And so connecting it to food is important. And looking at, well, this is kind of a laboratory unknown. Maybe that's going to be the problem. We haven't seen any legitimate evidence that they would contribute. And quite to the opposite, we got to get people eating more fruits and vegetables, and we got to get people eating more fiber. And so we're actually doing damage to people in these areas by saying that they cause cancer because people are afraid of the food they eat. The whole dirty dozen list, you're scaring people away from the best stuff they should be eating, the fruits and vegetables and fiber and things that we're not getting enough of. And so that's one I would really like to see go away.
Yeah, it is. I see it on social media all the time, and this is one thing that I'm so passionate about is this misinformation about if you can't eat organic, you shouldn't eat conventionally grown because of the blah, 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 blah. And we have so much data that shows that eating more fruits and vegetables, like you said, is beneficial for your health, regardless of if it's organic or not organic. And there's people out there that cannot afford organic produce, and to avoid conventional produce is
Yeah.
it's crazy. Like I just and I know it's driven from a place of fear and wanting to protect ourselves and all this stuff, but it's really this misinformation piece that's, like you said, not helping people and harming people as well.
Yeah, all the studies that have been done on this show that very clearly that that when you scare people about their food and they can't afford organic produce, they just don't eat
Hmm.
produce. And so that's on my farm we grow. My wife is a farmer. She came from Ukraine and farms, grew up farming, and so we grow fruits and vegetables, sell at farmers market every Saturday, and we have organic farmers there too. But we use a mix of organic and conventional strategies, whatever works best to be able to have the limited impact on our land and the safest products for our customers and for my family. We eat all the stuff we produce. So that's the big take home. Farmers are not trying to kill you. It's a lousy business model.
It's, yeah, you don't want to kill your consumer.
Yeah. Yeah, they don't like that. Yeah, no, they tend not to buy your product anymore.
Yeah. One person wrote in that they have food sensitivities and maybe GMOs are going to worsen their food sensitivities. I don't expect you to know about like food sensitivity specifically, but just from a scientific standpoint of how we're actually making these plants that may or may not make any sense in terms of our body is reacting to proteins, right? When they're in there.
That's right. And food sensitivity issues, most of those are occurring from crops that are not genetically engineered. So all of our gluten sensitivities and those are the main ones that we catch. Those are in non-genetically engineered wheat. The only genetically engineered wheat on the planet is in Argentina and not imported to the U.S. So food sensitivities, these are tested actually when they do the evaluation of a new genetically engineered trait, because we do know computationally what the epitopes are, or the protein signatures on a given protein that cause sensitivity. And you can test for that computationally before you ever make a genetically engineered plant. But then once you make it, how do you know that your genetic engineering change didn't cause some other change? That, like the elevation of a allergen in soy, for instance, and you can test for that. We know what the soy allergens are. So all of these things are very well tested, and even if they snuck through somehow, you would see it reflected in the population and then go back and test it. So the fact that we've done this for 30 years and haven't seen it suggests that that's not the case.
Unlikely. Makes sense. I'm going to keep going with the myths / are they facts kind of thing, and we can kind of go through these a little bit more rapid fire. You already addressed GMOs. You don't believe cause cancer, so we're going to move through that one. What about eating GMOs changes the consumer's DNA?
Absolutely false. There's no reason to believe that, because anything you eat, it doesn't change your DNA. Your DNA is pretty rigid stuff. It protects itself by keeping itself in high fidelity. And so you don't have a problem there.
GMO crops use more pesticides than conventional. I know we talked about it. Is this correct in terms of they use less insecticides? They do use more herbicides.
They use more herbicides, but the same herbicides per acre, just more acres of it. So the more metric tons of herbicide used per year.
Yes, but not per plant, which I think is what most people are thinking of.
In general, that's true. There are cases of resistance where we do use a little more and then use multiple herbicides, right. And that's a trend I would like to see change.
Yeah, that's one that feels like there needs to be. But it sounds like it's more than just the GMOs there. It's also like the nature of farming in general. Do you think that there's more layers to that than just the GMO piece?
Oh, absolutely. Yeah. On any farmer that's farming non-GMO and using herbicides for control are using different herbicides all the time. Right. You mix your strategies.
Yeah. GMO foods are less nutritious than organic foods.
That one is a conditional. So what we know from that is that we do know that when you grow, and the big meta-analyses on these have shown that they're basically equivalent, that you're getting the same out of both. There are some cases in organic crops where they're higher in polyphenols and higher polyphenols and anthocyanins, which are a type of polyphenol. You're getting higher levels of those types of compounds, which have been associated with good health. But just as kind of an aside, I have a friend who breeds strawberries who said, well, my strawberries have 10% more of polyphenols. And I said, yeah, but ours taste better. So people will eat 3 for every one of yours. And so it really is a question of access and how good it tastes. And so organic, great. If you can afford it, get it, enjoy it, buy it from a local farmer. But there's nothing wrong with the conventional counterpart. And if it's less expensive and you can buy more of it and eat twice as much, now you're getting 200%
Right.
of the nutrition.
Yeah. So looking at like your absolute intake versus, yeah, absolutely.
Yeah.
Um, GMOs are banned in most of Europe because they're unsafe, is the next one.
No, not really. They're banned in some countries in Europe because this goes back to the late 1900s when they were first looking at the technology. Many countries made decisions about that, mostly to protect local seed availability and farmers. Some countries, Spain grows lots of genetically engineered corn, but they only use the varieties from 1997 because they never approved new varieties in the EU. Romania grew genetically engineered potatoes and did great. They turned into a net exporter of potatoes and soybeans. Then they joined the EU in 2006 and had to quit that technology. And they became net importers again. So the EU is getting better, but it's not because it's dangerous.
Do you think you'll see in the future more genetically modified organisms in our food system in Europe?
Absolutely. So what they are now looking at in Europe is what we call gene editing. And this is where you're using the laboratory and the process of genetic engineering to just erase a few letters of DNA rather than add an entire gene. And in that process of gene editing, sometimes we call it CRISPR-Cas. That's a
Hmm.
common term of one type. We use gene editing. This is something Europe said we will not do it. The European Court of Justice refused. But now they're softening to that because they see this is a revolutionary technology that doesn't add risk and adds benefit to be able to come up with ways to take on new challenges that may come up in crop production. So, very important.
Interesting. The next one is that there's a belief that all GMOs are made by big corporations.
Well, good old Monsanto's been gone for 7 years. Most people don't even know that. It's they that was July of 2018. That company closed its doors, and radical changes to what happened next. Um, Small companies are trying to get in, and Okanagan Specialty Fruits came up with the Arctic apple. The Hawaiian papaya was done by co-ops in Hawaii, USDA and University of Hawaii. So the irony here is that the people who have opposed the technology have made the bar of entry so high that the only players who can do it are the big companies. So it's Syngenta, it's Bayer, it's the other one.
Yeah.
It's all the big companies.
You need to have enough
If you
money to
want,
be able to get into this at all. Yeah.
you have to have big bucks to be able to get through the regulatory process. Simplot had a potato. They're a rather large company that does potatoes. But if you want to have small companies participate, make it easier for small companies to participate.
Hmm. Hmm. Some people think that we don't need GMOs to feed the world and therefore we should not use them. And I think this is an interesting argument because you could say that about a lot of things that make our lives better, faster, more enjoyable. So I'm not sure why the need dictates this, but what would you say to that in terms of we don't need GMOs to feed the world, so we shouldn't?
Well, I agree with that to some degree because genetic engineering is one tool in the toolbox. The main thing that we need is constant genetic improvement through all methods. We need to be investing in more breeding, just crossing plants. We can do that faster these days with computational guidance. We need to be working on ways to deliver fertilizer better. We need to think of ways to save water, save land. All those things are how we're going to feed a hungry world. But genetic engineering is one part of that. And if we can make a rapid genetic change to meet one challenge, then that's a big step in the right direction. Organic farmers would do great would do very well by incorporating a little genetic engineering.
Hmm. Hmm. And just as we're wrapping up here, as a reminder, we've mentioned a few things throughout this podcast, but how do you view GMOs as actually helping people versus just for corporate profit? So we talked about nutritional quality, right? In terms of being able to put beta carotene in certain things, especially in populations that are at high risk for deficiency. You just mentioned potentially reducing the risk for drought intolerance. I think that's how you would say it in terms of making
Yeah,
it
drought
drought
tolerant. Yeah.
tolerance, which again would be beneficial for the people as well to make sure that they're fed despite the water that we have or don't have. What other things like that in terms of the consumer, how they could benefit from GMOs?
Yeah, so we mentioned earlier that this is a cornerstone of livestock feed and ethanol production. So, between meat and fuel, those are two things that consumers get benefit from in terms of price and access. And then that's hugely driven by genetic engineering. The other ones that are left on the shelf is things like celiac safe wheat. They've been able to engineer out some of the epitopes that contribute to celiac disease and gluten sensitivity. And that's something that just there hasn't been a big hunger for it but that would be a great
Mm-hmm.
example. Other ways to remove allergens from food so that people who have strawberry sensitivity or peach sensitivity, apple sensitivity, could get rid of those. We could edit those out very easily. You would have more flavors and aromas done on a much faster basis. There's all kinds of really great things like out there, like apples that are out there that have amazing banana and strawberry and apple and pineapple flavor, but they're too sensitive to disease or they flower at the wrong time. If we could add or edit a gene, that would be great. Oranges, it's citrus. There's so many things that we could do by just tweaking a gene or two that would allow us to have so much more complexity and character in the American diet and take us away from hyper processed foods, or ultra processed foods, which we know are delicious but not good for us. How do we make fruits and vegetables great again? and and that should be our big emphasis.
Hmm. Yeah, interesting. When you mentioned this idea that we could like celiac safe wheat or taking out epitopes in strawberries that are more likely to cause sensitivities, is there any concern from an immunological standpoint that doing so could actually increase the rates of certain allergies by affecting our tolerance as humans? Do you know what I mean by that?
I think so. I don't see that as being. I mean, it's certainly plausible, but not probable. I think we have a very good handle on things that can induce allergic reactions, and it's also easy to test.
Mm-hmm.
And so I think we have very good guidance starting, computationally before you ever even attempt to make a new product. You can make some pretty good estimates, and people have done that actually, and we just don't see it playing out in genetically engineered crops.
Okay. Anything else that you think that people should know listening to this podcast?
Well, I think the most important thing is that we have to think about what are our big goals going forward. And heading towards 2050, it's kind of a cliche to say, but we got to feed 2 billion more people at least. And we have to really up the amount of crops we can produce, but we don't have land to do it. In Florida here, we have 1,000 people moving here a day. All of our agricultural space is turning into subdivisions and strip malls. How are we going to feed the future? And it's going to be taking the land we have and intensifying what we grow on it. It's going to be coming up with better strategies for water, for fertilizer, for everything, and genetics in general of the foundational crop, just through traditional breeding. But then being able to add that one trait by changing a gene. That's where genetic engineering still will be a viable part of the future. So it's about the environment and environmental sustainability, about access of food for the food insecure, that's domestic and internationally, and then making sure farmers stay in business, and those things together are really, and then making better products for consumers. Those four things are why I get excited every day about these kinds of technologies.
Thank you so much, Kevin. You're a wealth of knowledge, and I learned. So you brought up a few topics that I'm like, oh wow, I really want to look more into that because this is something that I was just completely unaware of. So I appreciate your knowledge, and spreading all of this information to help us understand. And yeah, thank you.
Now, thank you for your time. I'm happy to reach out if there's ever any questions. And anybody who's listening, please drop me a line. I never don't answer an email.
Thank you, Kevin.
Thank you.